Chapter 1. Index Number. 1. Definition and meaning of index number. Price of an item, national income, supply, production, employment, unemployment, investment, import-export, cost of living, population of a country, birth rate, and death rate vary continuously with time. Generally, the proportion and direction of these variations also keep changing. It is important to study the variations in the price and quantity of an item with respect to change in time. The planning for the future can be suitably done from the knowledge of these changes. The changes taking place in the values of the variable at two different time periods can be measured by the following methods. Number 1. Method of absolute measure, that is difference, and number 2. Method of relative measure, that is ratio. Suppose the data regarding the average price per kilogram of two items, wheat and rice, for a month in the year 2015 and year 2016 are as follows. Item, price per kilogram in percentage. Year 2015, year 2016. Wheat 24, 30. Rice 40, 46. Number 1. Method of absolute measure, that is difference. The price of wheat in the year 2015 was Rs 24, which increased to Rs 30 in the year 2016. Thus, the price per kilogram increased in the year 2016 by Rs 6 with respect to the year 2015. Similarly, the price of rice has also increased by Rs 6. This is obtained by the absolute difference. Thus, it can be said that there is same rise in price in both the items. But this is not true in reality because the prices per unit of these items are not same in the year 2015. Thus, the base for comparative study of prices in 2016 is different. Hence, this method is not appropriate to compare the variations in a variable. We shall now study the method of relative measure which is used in such situations. Number 2. Method of relative measure, that is ratio. A ratio of price of the commodity in the year 2016 is obtained with the price in the year 2015 in this method to find the relative changes of the price of the item in the year 2016. Thus, ratio of prices of wheat is equal to 30 divided by 24 is equal to 1.25. Ratio of prices of rice is equal to 46 divided by 40 is equal to 1.15. It can be known for these ratios that the relative increase in the prices of wheat and rice in the year 2016 is not same. The price of wheat in the year 2016 is 1.25 times the price in the year 2015, whereas the price of rice is 1.15 times its price in the year 2015. Thus, it can be said that change in the price of wheat is more than the change in the price of rice. The ratios of prices of wheat and rice given here indicate the changes in prices at two different time periods. It is also called as relative change or price relative. Generally, the ratios are expressed as percentages to facilitate comparison. Hence, percentage change in the price of wheat is equal to 1.25 multiplied by 100 is equal to 125 and percentage change in the price of rice is equal to 1.15 multiplied by 100 is equal to 115. This is the relative percentage measure for the changes. Such a relative measure is called index number. Thus, the percentage change in the value of a variable associated with any item for the given, that is current period, compared to its value in a fixed, that is base period, is called an index number. The absolute method is not useful to find a measure for the overall change because many times the units expressing the prices of these two items may be different and it is not possible to combine the changes in these prices. The method of relative measure is used in such a situation. Since the relative measure is free from the unit of measurement, it is possible to combine the changes in the prices of the two items, and it is convenient to find a mathematical measure for these changes. Now, we shall take a relative measure for the overall change from the changes in prices of grains, wheat and rice. We shall denote the price for the year 2016 as P1 and the price of the year 2015 by P0. P0 is called base year price and P1 is called the current year price. The ratio P1 divided by P0 is called the price relative of that item. Item: price of base year 2015 in rupees P0. Price of current year 2016 in rupees P1. Price relative or relative change is equal to P1 divided by P0. Percentage of price relative is equal to P1 divided by P0 into 100. Wheat 24, 30, 30 divided by 24 is equal to 1.25, 125. Rice 40, 46, 46 divided by 40 is equal to 1.15 is equal to 1.15, 115. Total price relative or relative change 2.40. Percentage of price relative 240. The index obtained by multiplying the average of price relatives of the current year for these two items by 100 is called the price index number of the items for the current year. It is denoted by I. Thus, price index number of wheat and rice is equal to price relative of wheat plus price relative of rice whole upon number of items in 200 for the current year is equal to 1.25 plus 1.15 whole upon 2 into 100 is equal to 120. Hence, price index number of wheat and rice for the current year I is equal to 120. The price index number of wheat and rice J is equal to 120 indicates that there is an overall rise of 20% in the prices of the two items in the year 2016 as compared to the year 2015. Index number is a relative measure based on ratio. Similarly, measure for the overall change can be obtained using the relative method by combining changes in the values of more than two variables. We can define the general index number for a group as follows. The average of the percentage change in the value of a variable associated with one or more items for the given, that is, current period compared to its value in the fixed, that is, base period is called a general index number for the group. General index number for the group I is equal to sigma P1I upon P0I divided by n into 100, where general index number I is equal to index number of current period with respect to comparison period. P1I is equal to value of variable I for current period, that is I is equal to 1, 2, 3, 0, 0, 0 up to n. P0I is equal to value of variable I for comparison period, that is I is equal to 1, 2, 3 up to n. N is equal to number of values of the variable. Now, if we take a group of n such mutually related items, then an index is found using relative change in price of each item in that group. An average measure obtained from them is called the price index numbers for the groups. It can be written as general price index number I is equal to sigma P1I upon P0I divided by n into 100, where P1 is equal to price of item I in current period, that is I is equal to 1, 2, 3 up to n. P0 is equal to price of item I in base period, that is I is equal to 1, 2, 3 up to n. N is equal to number of items. Further, if we take a group of n such mutually related items, then an index is found using relative change in the quantity of each item in that group. An average measure obtained from them is called the quantity index number for the group. 2. Characteristics of index number. Some of the characteristics of index number deduced from its definition are as follows. 1. Index number is free from the unit as it is a relative measure. 2. The changes in the values of the variable having different units can be compared using index number. Hence, index number is a comparative measure. 3. Index number is a relative measure showing percentage change. 4. Index number is a spatial average. It has all the characteristics of an average. 5. The situation at two different periods can be compared by ratio with the standard, that is base period, using an index number. 3. Uses of index number. A general notion about the index number is an index number is only used to find a measure for changes in the value of a variable or the price level. But now its use is not limited to the study of change in the price level. The index number is used in various fields in the current revolutionary age. Index number is a useful statistical tool to study the challenges in the given economic, political, social, and industrial activities. Index number provides important guidance for planning the economic development of a country as it gives a comparative study of economic and industrial scenario of the country. Some of the uses of index number are as follows. Number 1. Index number for trade. This index number provides useful guidance to study the general situation of economic activities of business and trade in the country. Number 2. Wholesale price index number. This index number measures the changes in the general price level in the country. This index number is useful to the government, producers, and businessmen to take policy decisions such as knowing the demand and supply of items in the economy, estimating the future values, and planning the future. The Reserve Bank of India uses this index number to take necessary steps to control inflation by studying the changes in price levels. Using the wholesale price index number, the rate of inflation is found as follows. Rate of inflation is equal to wholesale index number of current year minus wholesale index number of previous year whole upon wholesale index number of previous year into 100. 3. Cost of living index number. This index number is useful to study the changes in the cost of living of people of different sections. This index number helps to determine purchasing power of money, salary to employees, dearness allowance, bonus to calculate real wage and to devise tax policies by the government. Number 4. Index number of human development. This index number is useful to determine the state of human resource, standard of living, life expectancy, and level of education, and it gives information about human resource development. Number 5. Index number of national income. This index number is useful to evaluate economic condition of the country and to determine targets for the 5-year plans by the government. The suggestions for increasing the national income, production and per capita income of the country can also be given using this index number by studying the changes in the national income of the country. Number 6. Index number of industrial production. This index number is very useful to study the changes in the production in industrial and craft fields. This index number is helpful to increase the rate of development of the country, planning industrial and trading activities. Number 7. Index number of agricultural production. This index number is useful to study the changes in the prices of agricultural production. The government plans agricultural policies using this index number. Moreover, this index number is helpful in forming policy to give proper support price to the farmers of their production. Number 8. Index number of import-export. This index number is useful to determine import-export policy, exchange rate, foreign exchange requirement, and the rate of excise on goods and to provide necessary suggestions. Number 9. Index number for employment. This index number provides the picture of employment, unemployment prevailing in the country. This shows the problems of unemployment which facilitates human resource planning. Number 10. Index number of capital investment. The changes in prices of shares and stocks debentures, government securities, and flow of capital investment can be studied by this index number. It also helps to estimate the trend of prices of share and stocks. Number 11. Index number of raw material. This index number provides necessary guidance to traders, businessmen, economists, etc. for the policies of production sales. As barometer is used to predict weather, air pressure, cyclone, and rain. The index number is a necessary tool for the measurement and comparative study of changes in the economic, business and social activities of the country. Hence, an index number is called the barometer of the economy of a country. 4. Base year. In the construction of index numbers, the value of a variable for the current period is compared with the value of the variable with a fixed period, that is, usually from the past. This fixed period or year is called the base year. The fixed year from the past can be the preceding year or any year before that. The period or year for which the value is to be compared with the base period or year is called the current period or year. The year selected as base year should be standard or normal. It should be free from natural calamities like floods, drought, earthquake, abnormal man-made events like war, revolt, riot, strike, agitation, political events, economic disturbance, or any unusual events. The base year can be selected in two ways. 1. Fixed base method. 2. Chain base method. Fixed base method. In this method, a stable period or year with usual events or situation is selected as a normal year or base year. But sometimes it becomes difficult to select a normal or base year. In this case, an average value of certain years is taken as the value of the variable for the base year. Index number is obtained by comparing value of the variable in the current year with the value of variable for the base year. The base year should be changed periodically so that it does not become a year of the distant past. The index number by fixed base method is obtained from the following formula. Index number I is equal to value of the variable in current year, that is period, divided by value of the variable in base year, that is period, into 100 is equal to P1 divided by P0 into 100, where P1 is equal to value of the variable in current year, that is period. P0 is equal to value of the variable in base year, that is period. Illustration 1. The data about average daily wage of a group workers employed in a factory in a city during the year 2008 to 2015 are as follows. Find the index number by 1. Fixed base price, that is taking base year 2008. 2. Chain base method, and 3. Fixed base method by taking average of average daily wages of the year 2011 to 2013 as the wage for the base year. Here, average daily wage in rupees 2008 275, 2009 284, 2010 289, 2011 293, 2012 297, 2013 313, 2014 328, 2015 345. Here, average daily wage 1. Fixed base price base year 2008 P0 is equal to 275. Index number is equal to P1 divided by P0 into 100. 2. Chain base index number is equal to value of the variable for current year, that is period, divided by value of the variable for preceding year, that is period, into 100. 3. Average salary index number PO is equal to 2011 to 2013 average daily salary is equal to 293 plus 297 plus 313 divided by 3 is equal to 903 divided by 3 is equal to 301. I is equal to P1 divided by P0 into 100. 2008 275 is equal to 100 is equal to 100. 275 divided by 301 into 100 is equal to 91.36. 2009. 284. 284 divided by 275 into 100 is equal to 103.27. 284 divided by 275 into 100 is equal to 103.27. 284 divided by 301 into 100 is equal to 94.35. 2010. 289. 289 divided by 275 into 100 is equal to 105.09. 289 divided by 284 into 100 is equal to 101.76. 289 divided by 301 into 100 is equal to 96.01. 2011. 293. 293 divided by 275 into 100 is equal to 106.55. 293 divided by 289 into 100 is equal to 101.38. 293 divided by 301 into 100 is equal to 97.34. 2012. 297. 297 divided by 275 into 100 is equal to 108.00. 297 divided by 293 into 100 is equal to 101.37. 297 divided by 301 into 100 is equal to 98.67. 2013. 313. 313 divided by 275 into 100 is equal to 113.82. 313 divided by 297 into 100 is equal to 105.39. 313 divided by 301 into 100 is equal to 103.99. 2014. 328. 328 divided by 275 into 100 is equal to 119.27. 328 divided by 313 into 100 is equal to 104.79. 328 divided by 301 into 100 is equal to 108.97. 2015. 345. 345 divided by 275 into 100 is equal to 125.45. 345 divided by 328 into 100 is equal to 105.18. 345 divided by 301 into 100 is equal to 114.62. Illustration 2. The prices per unit in rupees of 6 food items in the year 2014 and 2015 are given in the following table. Taking 2014 as the base year, compute the general index number for the price of food items and state the overall rise in prices of these food items. Item, unit, price per unit in rupees of the item, year 2014, year 2015. Bread, packet, 25, 28. Eggs, dozen, 30, 35. Ghee, tin, 375, 380. Milk, liter, 36, 40. Cheese, kilogram, 440, 500. Butter, kilogram, 265, 300. A general index number for the price of these items for the current year 2015 is to be obtained with the base year 2014. We will find price relatives P1 divided by P0 by taking base year price as PO and current year price as P1. Answer. Item, price of item in rupees. Price relative is equal to P1 divided by P0. In price of item in rupees, P0, P1. Bread, 25, 28. 28 divided by 25 is equal to 1.1200. Eggs, 30, 35. 35 divided by 30 is equal to 1.1666. Ghee, 375, 380. 380 divided by 375 is equal to 1.0133. Milk, 36, 40. 40 divided by 36 is equal to 1.1111. Cheese 440, 500. 500 divided by 440 is equal to 1.1364. Butter 265, 300. 300 divided by 265 is equal to 1.1321. Total 6.6795. General index number of 6 food item I is equal to sigma P1 upon P0 divided by n into 100 is equal to 6.6795 divided by 6 into 100 is equal to 111.33. Therefore, general price index number of 6 food items is I is equal to 111.33. It can be seen from the value of the index number I that there is an overall rise in prices of food items by 111.33 minus 100 is equal to 11.33% in the year 2015 as compared to the year 2014. Merits and limitations of fixed base method. Merits. 1. Uniformity is maintained in calculation and comparison of the relative changes in the values of the variable as the base year is constant in this method. 2. This method is useful to compare the long-term changes in the values of the variable. 3. This method is easy to understand and compute. Limitations. 1. The taste, habits, and fashion of consumers change with the time and hence there is a change in the items used by the consumer. The items with reduced use which were used in the past cannot be removed in this method. 2. It is not always possible to have a standard year with normal condition as the base year. Therefore, selection of the base year is difficult. The reliability of the index number reduces if the base year is not selected appropriately. 3. This method is not suitable to compare the short-term changes in the value of the variable. 4. The quality of selected items keeps changing. It is not possible to make any change in their weights in this method. 5. If the base year is a year of very remote past, the comparison cannot be considered to be appropriate. Chain-based method. A fixed year or period is not taken as a base year or period in this method. For every current year, its preceding year is taken as a base year. For example, the year 2015 is taken as a base year for the index number of the year 2016. The base year keeps changing in this method. Since the base year is repeatedly changed, this method is called chain-based method. The current situation is compared with the recent past situation in this method. The index number by this method is found using the following formula. Index number is equal to value of the variable for current year, that is period, divided by value of the variable for preceding year, that is period, into 100. I is equal to P1 divided by P0 into 100. Illustration 3. The chain-based index numbers of agricultural production of a state from the year 2008 to 2014 are as follows. Compute the fixed base index numbers, that is, take 2007 as base year. Year, index number of agricultural production, 2008, 100, 2009, 110, 2010, 95, 2011, 108, 2012, 120, 2013, 106, 2014, 110. Base year is equal to 207. So index number of 207 is 100. Year, index numbers of agricultural production. Fixed base index numbers is equal to value of variable in current year into value of variable in preceding year divided by 100. 2008, 100, 100 into 100 divided by 100 is equal to 100.00. 2009, 110, 110 into 100 divided by 100 is equal to 110.00. 2010, 95, 95 into 110 divided by 100 is equal to 104.00. 2011, 108, 108 into 104.00 divided by 100 is equal to 112.86. 2012, 120. 120 into 112.86 divided by 100 is equal to 135.43. 2013, 106. 106 into 135.43 divided by 100 is equal to 143.56. 2014, 110. 110 into 143.56 divided by 100 is equal to 157.92. Merits and limitations of chain-based method. Merits. 1. The problem of selecting the base year does not arise in this method because at any given time the preceding year, that is period, is taken as the base year, that is period. 2. As the comparison is with the preceding year, new items can be included according to the taste and choice of the consumer. It is possible to remove the items not in use. 3. This method is useful in the fields of economics, trade, and commerce as the value of the variable in the current period is compared with the period in the recent past. Limitations. 1. This method is suitable only for short-term comparison of the value of the variable in the current period as the preceding year is taken as the base year. The method is not very convenient for long-term comparison. 2. If there is an error in the calculation of index number by this method, then the effect of that error continues in the interpretation of the index number of the succeeding year. 3. There is no uniformity in the computation of index numbers obtained by this method. 4. If the information for a year is not available, then the index number for the next year cannot be obtained. Illustration 4. The data about purchase of groundnut by an edible oil mill from the year 2008 and 2015 are as follows. Prepare the index numbers by fixed base method with the year 2008 as the base year with chain base and by taking the average quantity purchased in the year 2010 and 2011 as the purchase for the base year. Year. Purchase of groundnut, that is ton. 2008 230, 2009 250, 2010 230, 2011 250, 2012 270, 2013 280, 2014 300, 2015 300. Year. Quantity purchase of groundnut, that is ton. Index number with base year 2008 is equal to value of the variable in current year divided by value of the variable in base year into 100. Chain base index number is equal to value of the variable in current year divided by value of the variable in preceding year into 100. Average of quantity in year 2010 and 2011 is equal to 230 plus 250 divided by 2 is equal to 240 as base year quantity. 2008 230 is equal to 100 is equal to 100. 230 divided by 240 into 100 is equal to 95.83. 2009 250 divided by 230 into 100 is equal to 108.70. 250 divided by 230 into 100 is equal to 108.70. 250 divided by 240 into 100 is equal to 104.17. 2010 230 divided by 230 into 100 is equal to 100. 230 divided by 250 into 100 is equal to 92.00. 230 divided by 240 into 100 is equal to 95.83. 2011 250 divided by 230 into 100 is equal to 108.70. 250 divided by 230 into 100 is equal to 108.70. 250 divided by 240 into 100 is equal to 104.17. 2012 270 divided by 230 into 100 is equal to 117.39. 270 divided by 250 into 100 is equal to 108. 270 divided by 240 into 100 is equal to 112.5. 2013 280. 280 divided by 230 into 100 is equal to 121.74. 280 divided by 270 into 100 is equal to 103.70. 280 divided by 240 into 100 is equal to 116.67. 2014 300. 300 divided by 230 into 100 is equal to 130.43. 300 divided by 280 into 100 is equal to 107.14. 300 divided by 240 into 100 is equal to 125. 2015 300. 300 divided by 230 into 100 is equal to 130.43. 300 divided by 300 into 100 is equal to 100. 300 divided by 240 into 100 is equal to 125. Illustration 5. The following data are obtained about the annual average prices of wheat, rice and sugar in the wholesale market of a city. Find the general index number for 3 items by fixed base method with base year 2011 and by chain base method. Item and year: wheat, rice, sugar. 2011 18, 30, 30. 2012 80.50, 36, 31. 2013 18.90, 38, 32. 2014 19, 38, 34. 2015 19.50, 39, 36. Item: price rupees. Fixed base index number is equal to value of the variable in current year divided by value of the variable in base year into 100. Base year 2011. 2011, 2012, 2013, 2014, 2015. Wheat 100. 18.50 divided by 18 into 100 is equal to 102.78. 18.90 divided by 18 into 100 is equal to 105.00. 19 divided by 18 into 100 is equal to 105.56. 19.50 divided by 18 into 100 is equal to 103.33. Rice 100. 36 divided by 30 into 100 is equal to 120.00. 38 divided by 30 into 100 is equal to 126.67. 38 divided by 30 into 100 is equal to 126.67. 39 divided by 30 into 100 is equal to 130.00. Sugar 100. 31 divided by 30 into 100 is equal to 103.33. 32 divided by 30 into 100 is equal to 106.67. 34 divided by 30 into 100 is equal to 113.33. 36 divided by 30 into 100 is equal to 120.00. Total 300, 326.11, 338.34, 345.56, 358.33. General index number is equal to total divided by 3. 300 divided by 3 is equal to 100. 326.11 divided by 3 is equal to 108.70. 338.34 divided by 3 is equal to 112.78. 345.56 divided by 3 is equal to 115.19. 358.33 divided by 3 is equal to 119.44. Item: price rupees. Chain base index number is equal to value of the variable in current year divided by value of the variable in base year. into 100, 2011, 2012, 2013, 2014, 2015. With 100, 18.50 divided by 18 into 100 is equal to 102.78. 18.90 divided by 18.50 into 100 is equal to 102.16. 19 divided by 18.90 into 100 is equal to 100.53. 19.50 divided by 19 into 100 is equal to 102.63. Rise 100. 36 divided by 30 into 100 is equal to 120.00. 38 divided by 36 into 100 is equal to 105.56. 38 divided by 38 into 100 is equal to 100.00. 39 divided by 38 into 100 is equal to 102.63. Sugar 100. 31 divided by 30 into 100 is equal to 103.33. 32 divided by 31 into 100 is equal to 103.23. 34 divided by 32 into 100 is equal to 106.25. 36 divided by 34 into 100 is equal to 105.88. Total 300. 326.11, 310.95, 306.78, 311.14. General index number is equal to total divided by 3. 300 divided by 3 is equal to 100. 326.11 divided by 3 is equal to 108.70. 310.95 divided by 3 is equal to 103.65. 306.78 divided by 3 is equal to 102.26. 311.14 divided by 3 is equal to 103.71. Illustration 6. The following data are available about the crimes in a city. Find the general index number by fixed base price method, considering the year 2010 as base year. Types of crime. Year 2007, 2008, 2009, 2010. Murder 110, 128, 134, 129. Violence and rape 30, 45, 40, 48. Robbery 610, 720, 770, 830. Theft of property 2450, 2630, 2910, 2890. Fixed base index number I is equal to value of the variable in current year, that is period, divided by value of the variable in base year, that is period, into 100. Type of crime. Year 2007, 2008, 2009, 2010. Murder 110 divided by 129 into 100 is equal to 85.27. 128 divided by 129 into 100 is equal to 99.22. 134 divided by 129 into 100 is equal to 103.88. 129 divided by 129 into 100 is equal to 100. Violence and rape 30 divided by 48 into 100 is equal to 62.5. 45 divided by 48 into 100 is equal to 93.75. 40 divided by 48 into 100 is equal to 83.33. 48 divided by 48 into 100 is equal to 100. Robbery 610 divided by 830 into 100 is equal to 73.49. 720 divided by 830 into 100 is equal to 86.75. 770 divided by 830 into 100 is equal to 92.77. 830 divided by 830 into 100 is equal to 100. Theft of property. 2450 divided by 2890 into 100 is equal to 84.78. 2630 divided by 2890 into 100 is equal to 91.00. 2910 divided by 2890 into 100 is equal to 100.69. 2890 divided by 2890 into 100 is equal to 100. Total 306.04, 370.72, 380.67, 400. General index number of crime is equal to total divided by 4. 306.04 divided by 4 is equal to 76.51. 370.72 divided by 4 is equal to 92.68. 380.67 divided by 4 is equal to 95.17. 400 divided by 4 is equal to 100. 5. Conversion from fixed base to chain base and from chain base to fixed base. Generally, whenever the fixed base or chain base index numbers only are available instead of the original information about the values of the variable, the conversion of base is necessary for the following reasons. If the need arises to find the short-term changes in the values of the variable, then it becomes difficult to find it from the fixed base index numbers. It is easier to find the short-term variations after converting the given fixed base index numbers into chain base index numbers. Sometimes, it is necessary to compare the value of the variable at a given period to the value of another period in a series of values of the variable. This is not possible if only chain base index numbers are available. The above comparison is possible in this situation if the chain base index numbers are converted to the fixed base index numbers. Thus, it is necessary to convert the chain base index numbers into the fixed base index numbers. Hence, the base conversion is carried out. Conversion of the fixed base index number to the chain base index numbers is as follows. Chain base index number is equal to fixed base index number of current year divided by fixed base index number of preceding year into 100. Illustration 7. The fixed base index numbers of food from the month of January to October in the year 2015 for the industrial workers of Ahmedabad are as given below. Compute the chain base index numbers. Month: January, February, March, April, May, June, July, August, September, October. Index number of food: 271, 270, 268, 268, 278, 283, 283, 293, 293, 299. Month: index number of food. Chain base index numbers is equal to fixed base index number of current year divided by fixed base index number of preceding year into 100. January 271 is equal to 100. February 270. 271 divided by 270 into 100 is equal to 99.63. March 268. 268 divided by 270 into 100 is equal to 99.26. April 268. 268 divided by 268 into 100 is equal to 100. May 278. 278 divided by 268 into 100 is equal to 103.73. June 283. 283 divided by 278 into 100 is equal to 101.80. July 283. 283 divided by 283 into 100 is equal to 100. August 293. 293 divided by 283 into 100 is equal to 103.53. September 293. 293 divided by 293 into 100 is equal to 100. October 299. 299 divided by 293 into 100 is equal to 102.05. Conversion of chain base index numbers to fixed base index number. If the year-wise chain base index numbers are given, the fixed base index number can be found accordingly. To obtain the fixed base index numbers, the chain base index number of that year is multiplied by the fixed base index number of the previous year and the product is divided by 100. Thus, fixed base index number of current year is equal to chain base index number of the current year into fixed base index number of the preceding year to current year whole upon 100. Illustration 8. The chain base index numbers obtained for food items for the year 2008 to 2009 to 2015 to 2016 are as follows. Compute the fixed base index numbers. Take 2007 to 2008 as base year. Year. Index number of food items 2008 to 2009 134.8. 2009 to 2010 115.28. 2010 to 2011 115.57. 211 to 212 107.29. 212 to 213 109.91. 213 to 214 112.80. 2014 to 2015 106.24. 2015 to 2016 102.48. The year 2007 to 2008 is to be taken as the base year here. Hence, the fixed index number for the year 2008 to 2009 will not change. Current year fixed base index number is equal to current year chain base index number into fixed base index number of the preceding year to current year whole upon 100. Here, index number of food items, fixed base index number 2008 to 2009 134.8 is equal to 134.8. 2009 to 2010 115.28. 115.28 into 134.8 divided by 100 is equal to 155.40. 2010 to 2011 115.57. 115.57 into 155.40 divided by 100 is equal to 179.60. 2011 to 2012 107.29. 107.29 into 179.60 divided by 100 is equal to 192.69. 2012 to 2013 109.91. 109.91 into 192.69 divided by 100 is equal to 211.79. 2013 to 2014 112.80. 112.80 into 211.79 divided by 100 is equal to 238.9. 2014 to 2015 106.24. 106.24 into 238.9 divided by 100 is equal to 253.81. 2015 to 2016 102.48. 102.48 into 253.81 divided by 100 is equal to 260.10. 6. Specific formula for computing index number. We have seen that the index number is useful to study the changes in the values of variable for an item or the values of variables for items in a group. Simple average is used in the construction of an index number and every item is given equal weightage. But the importance of every item is generally not same in practice. For example, the importance given to grains is not same as the importance given to vegetables, pulses, or edible oil. Thus, the index number of food will be more realistic and meaningful if each item is assigned weight according to its importance. The weights of items included are decided in the construction of different types of index numbers. Generally, the weights given to the items for constructing the index number are determined on the basis of their quantity consumed. Some specific formula for computing index numbers by taking this fact into consideration, where different methods of selecting weights are taken for the construction of index number. Method of weighted average. Suppose II is the index number of the ith group among the groups of items or items, weight, rice, and pulses with the corresponding weight Wi, then the general index number of these groups is obtained using the following formula. General index number I is equal to sigma IIWI divided by sigma WI is equal to sigma IW divided by sigma W. For example, if the index numbers of these groups are 120, 150 and 300 respectively, and their corresponding weights are 3, 2 and 1, then the general index number for the group of items is I is equal to sigma IW divided by sigma W is equal to 120 into 3 plus 150 into 2 plus 300 into 1 divided by 3 plus 2 plus 1 is equal to 360 plus 300 plus 300 divided by 6 is equal to 960 divided by 6 is equal to 160. Last pair's formula. This method of finding the index number is given by last pair. It is one of the important methods of finding index number. In this method, base year price is denoted by P0 and the quantity is denoted by Q0, whereas the prices of items in the current year are denoted by P1. The expenditure P0, Q0 is assigned as weight to the price relative P1 upon P0. The formula of weighted index number thus obtained is called the formula of last pair's index, which is denoted by IL. The last pair's formula is as follows. Last pair's index number IL is equal to sigma P1 upon P0 into P0 Q0 divided by sigma P0 Q0 into 100 is equal to sigma P1 upon P0 into P0 Q0 divided by sigma P0 Q0 into 100. IL is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100. Passe's formula. This method is given by an economist named Passe. If we denote P0 as base year price, P1 as current year price, and Q1 as current year quantity, then the expenditure P0 Q1 is assigned as weight for the price relative P1 divided by P0. The formula of weighted index number thus obtained is called the formula of Passe's index number, which is denoted by IP. The formula of Passe's index number is as follows. Passe's index number IP is equal to sigma P1 upon P0 into P0 Q1 divided by sigma P0 Q1 into 100 is equal to sigma P1 upon P0 into P0 Q1 divided by sigma P0 Q1 into 100. IP is equal to sigma P1 Q1 divided by sigma P0 Q1 into 100. Fisher's formula. The base year and current year quantities are taken into consideration for computing the weight is last pair's and Passe's method respectively. Professor Irving Fisher has constructed an index number by considering quantities of both the years. The geometric mean of last pair's and Passe's index numbers is called Fisher's index number, which is denoted by IF. The formula of Fisher's index number is as follows. Fisher's index number IF is equal to square root IL into IP. Fisher's index number IF is equal to under root sigma P1 Q0 divide by sigma P0 Q0 into sigma P1 Q1 divide by sigma P0 Q1 into 100. The Fisher's index number is called ideal index number due to the following reasons. 1. The quantities of both the years, base year and current year, are taken in the computation for constructing this index number. 2. This index number satisfies both the important fundamental test, time reversal and factor reversal test of index numbers. 3. The geometric mean is used to calculate this index number, which is the best average for the construction of index number. 4. This index number is free from base as it balances the demerits of last year's and past year's index number. Thus, Fisher's index number is an ideal index number. Illustration 9. The following data are obtained from the Family Budget Inquiry of Middle Class People. State the change in the cost of living in the year 2015 with respect to the year 2013 by finding the index number. If the average monthly disposable income of a family in the year 2013 is Rs 15,000, then obtain the estimate of the necessary average monthly disposable income in the year 2015. Group: food, fuel, electricity, rent, clothing, miscellaneous. Weight: 45, 15, 10, 20, 10. Expenditure in 2013 in rupees: 3,000, 1,450, 1,500, 600, 1,600. Expenditure in 2015 in rupees: 3,900, 1,850, 2,400, 900, 1,920. We will take P0 is equal to expenditure in 2013 and P1 is equal to expenditure in 2015. Group: weight, W. Expenditure in 2013 in rupees P0. Expenditure in 2015 in rupees P1. Expenditure I is equal to P1 divided by P0 into 100. IW. Food: 45, 3,000, 3,900, 3,900 divided by 3,000 into 100 is equal to 130. 5,850. Fuel, electricity: 15, 1,450, 1,850, 1,850 divided by 1,450 into 100 is equal to 127.6. 1,914. Rent: 10, 1,500, 2,400, 2,400 divided by 1,500 into 100 is equal to 160, 1,600. Clothing: 20, 600, 900, 900 divided by 600 into 100 is equal to 150, 3,000. Miscellaneous: 10, 1,600, 1,920, 1,920 divided by 1,600 into 100 is equal to 120, 1,200. Total sigma W is equal to 100. Sigma IW is equal to 13,564. Index number by family budget method. I is equal to sigma IW divided by sigma W is equal to 13,564 divided by 100 is equal to 135.64. Thus, it can be said that there is a rise of, that is 135.64 minus 100 is equal to 35.64% in the cost of living in the year 2015 as compared to 2013. Average monthly disposable income of a family in the year 2013 is Rs 15,000. Thus, the percentage increase in the cost of living index number in the year 2015 is equal to average monthly expenditure of 2013 into cost of living index number of 2015 divided by 100 is equal to 15,000 into 135.64 divided by 100 is equal to 20,34,600 divided by 100 is equal to rupees 20,346. Illustration 10. Find last year's, past year's and Fisher's index numbers for the year 2016 with base year 2015 from the data about price and consumption of food items given below. Item, unit, year 2016, price in rupees, quantity, year 2015, price in rupees, quantity. Rice, kilogram, 40, 1.5 kilogram, 39, 1 kilogram. Milk, liter, 44, 10 liter, 40, 12 liter. Bread, kilogram, 50, 1.5 kilogram, 45, 2 kilogram. Banana, dozen, 36, 1.5 dozen, 30, 2 dozen. We will take price P0 and quantity Q0 for the base year, price P1 and quantity Q1 for the current year. Item, unit, P0, Q0, P1, Q1, P1, Q0, P0, Q0, P1, Q1, P0, Q1. Rice, kilogram, 39, 1, 40, 1.5, 40, 39, 60, 58.5. Milk, liter, 40, 12, 44, 10, 528, 480, 440, 400. Bread, kilogram, 45, 2, 50, 1.5, 100, 90, 75, 67.5. Banana, dozen, 30, 2, 36, 1.5, 72, 60, 54, 45. Total, 740, 669, 629, 571. Last payer's index number IL is equal to sigma P1Q0 divided by sigma P0Q0 into 100 is equal to 740 divided by 669 into 100 is equal to 110.6128 is equal to 110.61. Thus, there is a rise of 110.61 minus 100 is equal to 10.61% in prices of the year 2016 as compared to the base year 2015. Passes index number IP is equal to sigma P1Q1 divided by sigma P0Q1 into 100 is equal to 629 divided by 571 into 100 is equal to 110.1576 equals to 110.16. Thus, there is a rise of 110.16 minus 100 is equal to 10.16% in prices of the year 2016 as compared to the base year 2015. Fisher's index number IF is equal to square root IL into IP is equal to square root 110.61 into 110.16 is equal to 110.3847 equals to 110.38. Thus, there is a rise of 110.38 minus 100 is equal to 10.38% in prices of the year 2016 as compared to the base year 2015. Illustration 11. Find the idle index number for the year 2015 from the following data. Item, base year 2014, price in rupees, quantity. Current year 2015, price in rupees, quantity. A. 16, 10, 20, 11. B. 20, 9, 24, 9. C. 32, 16, 40, 17. Fisher's index number is considered as an idle index number. So, we will find Fisher's index number here. We will take price P0 and quantity Q0 for base year, price P1 and quantity Q0 for the current year. Item, P0, Q0, P1, Q1, P1, Q0, P0, Q0, P1, Q1, P0, Q1. A. 16, 10, 20, 11, 200, 160, 220, 176. B. 20, 9, 24, 9, 216, 180, 216, 180. C. 32, 16, 40, 17, 640, 512, 680, 544. Total 1056, 852, 1116, 900. Fisher's index number IF is equal to under root sigma P1 Q1 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100 is equal to under root 1056 divided by 552 into 1116 divided by 900 into 100 is equal to under root 1.5369 into 100 is equal to 1.2397 into 100. IF is equal to 123.97. Thus, it can be said that there is 123.97 minus 100 is equal to 23.97% rise in the prices in the year 2015 as compared to the year 2014. Illustration 12. Find the passes and Fisher's index numbers for the year 2015 with the base year 2014 using the data given below. Item A, B, C, D, E. Year 2014 price in rupees. Total expenditure 100, 400, 100, 500, 150, 600, 180, 1080, 250, 1000. Year 2015 price in rupees. Total expenditure 120, 720, 120, 600, 160, 800, 200, 1000, 300, 1200. The consumption and total expenditure for the items are given here. Total expenditure of item is equal to price of item per unit into consumption of item. Consumption of item is equal to total expenditure of item divided by price of item per unit. Item base year 2014 P0 Q0 is equal to total expenditure divided by P0. Current year 2015 P1 Q1 is equal to total expenditure divided by P1. P1 Q0 P0 Q0 P1 Q1 P0 Q1. A 100 400 divided by 100 is equal to 4. 120 720 divided by 120 is equal to 6. 480 400 720 600. B 100 500 divided by 100 is equal to 5. 120 600 divided by 120 is equal to 5. 600 500 600 500. C 150 600 divided by 150 is equal to 4. 160 800 divided by 160 is equal to 5. 640 600 800 750. D 180 1080 divided by 180 is equal to 6. 200 1000 divided by 200 is equal to 5. 1200 1080 1000 900. E 250 1000 divided by 250 is equal to 4. 300 1200 divided by 300 is equal to 4. 1200 1000 1200 1000. Total sigma P1 Q0 is equal to 4120. Sigma P0 Q0 is equal to 3580. Sigma P1 Q1 is equal to 4320. Sigma P0 Q1 is equal to 3750. Passes index number is equal to IP is equal to sigma P1 Q1 divided by sigma P0 Q1 into 100 is equal to 4320 divided by 3580 into 100 is equal to 1.152 into 100 is equal to 115.2. Fisher's index number is equal to IF is equal to under root sigma P1Q0 divided by sigma P0Q0 into sigma P1Q1 divided by sigma P0Q1 into 100 is equal to under root 4120 divided by 3580 into 4320 divided by 3750 into 100 is equal to under root 1.1508 into 1.152 into 100 is equal to under root 1.3257 into 100 is equal to 1.1514 into 100. IF is equal to 115.14. Thus, Passes index number is equal to 115.2 and Fisher's index number is equal to 115.14. Illustration 13. The Health Department has implemented a certain policy for the industrial units in the year 2003 to control the possibility of cancer due to the chemical process which is hazardous to the health of workers employed in the industrial units of a certain industrial area who are residing in the same area. To evaluate this policy, a survey was conducted about deaths due to cancer of persons in the different age groups. The following data are obtained for the years 2003 and 2008. Find the index number of deaths due to cancer using weighted average method by taking the population of this industrial area in the year 2003 as weight and interpret it. Age group in years. Population in year 2003 in thousand. Deaths in year 2003. Deaths in year 2008. Less than 5, 10, 265. 5 to 15, 8, 145, 100. 15 to 40, 48, 610, 480. 40 to 60, 38, 350, 225. Greater than 60, 14, 550, 465. We shall obtain the general index number by finding the relative percentages of cancer deaths for the year 2008 and taking the population in different age groups in 2003 as weights. Age group in years. Population in year 2003 in thousand W. Deaths in year 2003 P0. Deaths in year 2008 P1. I is equal to P1 divided by P0 into 100 IW. Less than 5, 10, 200, 65. 65 divided by 200 into 100 is equal to 32.5. 325. 5 to 15. 8, 145, 100. 100 divided by 145 into 100 is equal to 68.97. 551.76. 15 to 40. 48. 610. 480. 480 divided by 610 into 100 is equal to 78.69. 3777.12. 40 to 60. 38. 350. 225. 225 divided by 350 into 100 is equal to 64.29. 2443.02. Greater than 60. 14. 550. 465. 465 divided by 550 into 100 is equal to 84.55. 1183.7. Total 118. 8280.6. Index number for year 2008. I is equal to sigma IW divided by sigma W is equal to 8280.6 divided by 118 is equal to 70.1745 equals to 70.17. Thus, it can be said that there is a decrease of 100 minus 70.17 is equal to 29.83% in the deaths due to cancer in the year 2008 as compared to the year 2007. Cost of living index number. The cost of living index number is constructed to measure and study the changes in the cost of living of people from different sections of the society due to the fluctuations in prices. Thus, the number showing the percentage of relative changes in the cost of living of the people of a certain section of the society in the current year, that is period, as compared to the base year, that is period, is called the cost of living index number. The cost of living index number is prepared separately for the people of different sections of the society and regions. For example, a family spends Rs 15,000 per month for their living in the year 2012 and the same family spends Rs 18,000 per month for their living in the year 2014 for the same lifestyle. Their cost of living index number can be obtained as follows. Cost of living index number is equal to current year, that is period, monthly expenditure divided by base year, that is period, monthly expenditure into 100 is equal to 18,000 divided by 15,000 into 100 is equal to 600 divided by 5 is equal to 120. Thus, it can be said that there is a rise of 120 minus 100 is equal to 20% in the monthly expense in the year 2014 as compared to the year 2012. Construction of cost of living index number. The following points should be considered while constructing the cost of living index number. 1. Purpose. The purpose of every index number should be explained before constructing it. We should ascertain the class of people in the society for whom the cost of living index number is to be constructed. The requirements of the people of worker class and rich class are different. For example, the rise in price of grains does not affect much to the cost of living of the people from rich class, whereas it affects a lot to the cost of living of the people from worker class. Thus, it is necessary to clarify the purpose of the construction of the cost of living index number. 2. Family budget inquiry. A sample of some families is randomly selected from the families of that class of people for whom the cost of living index is to be prepared. The budget of the families selected in the sample is studied. The information is obtained about the list of different items consumed by them, their consumption, list of retail prices, the expenses incurred on them and place of purchase, etc. This type of inquiry is called sample family budget inquiry. The data obtained from the inquiry of families included in the sample are generally divided into 5 sections. A. Food. B. Clothing. C. House rent. D. Fuel and electricity. And E. Miscellaneous. The importance of different items in the expenditure for living can be known from the sample inquiry of family budget. Hence, the importance of each item selected in the construction of the index number in its group and the importance of each group in the total expenditure can be determined. 3. Availability of prices of items. The retail prices of items are collected from the areas of residence of the people from the class of families for whom the cost of living index number is to be obtained. As far as possible, these prices should be collected from the standard or government approved shops. The average price of items should be taken into consideration when the prices obtained from various shops at different times are different. 4. Base year. A normal year is selected as a base year. The price relatives are found as follows for each item by taking the retail prices of the normal year as the base year prices. Price relative I is equal to P1 divided by P0 into 100, where P1 is equal to retail price of item in current year. P0 is equal to retail price of item in base year. 5. Average. It is necessary to find a general price relative from the price relatives of different items. A proper average should be used for this purpose. Theoretically, the geometric mean is the ideal average for the construction of index number. But due to the difficulty of its computation, it is common to use the weighted mean for the construction of index number. 6. Weight. The importance of different items selected in the construction of index number is not same. The number associated with items in proportion to their importance is called weight. These weights can be of two types. 1. Implicit weight and 2. Explicit weight. 1. Implicit weight. This is an indirect method of assigning weights. According to this method, the weights are determined as per the number of varieties of different items selected in the construction of index number. This method is called implicit method as the weights cannot be accurately quantified. 2. Explicit weight. This is a direct method of assigning weights. The weights of items are expressed numerically in proportion to their importance. In this method, the weights of items are determined according to the consumption, sale, production or the expenditure for that item. Thus, the weights given in accordance with the importance of the items are called explicit weights. The two methods of assigning explicit weight are as follows. 1. Method of total expenditure. 2. Method of family budget. 1. Method of total expenditure. In this method, the expenditure for every item in the base year and current year is found using the consumption of these items, and further the total expenditure of all the items is obtained for the both the years. The percentage ratio of the total expenditure of the current year with the total expenditure of the base year is called the index number by the method of total expenditure. Suppose P0 is equal to price of base year, P1 is equal to price of current year, Q0 is equal to quantity of base year, Q1 is equal to quantity of current year. If the quantity of the base year is used for finding the total expenditure of the current and base year, sigma P1 Q0 is equal to total expenditure of current year and sigma P0 Q0 is equal to total expenditure of base year. Index number I is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100. This formula is the formula of last payer's index number. If the quantity of the current year is used for finding the total expenditure of the current and base year, sigma P1 Q1 is equal to total expenditure of current year and sigma P0 Q1 is equal to total expenditure of base year. Index number I is equal to sigma P1 Q1 divided by sigma P0 Q1 into 100. This formula is the formula of passes index number. 2. Method of family budget. In this method, the percentage price relative I is found first for every item. Here, I is equal to P1 divided by P0 into 100, where P1 is equal to price of current year and P0 is equal to price of base year. Then, the expenditure of every item P0 Q0 in the base year is found and it is taken as the weight W for the percentage price relative I. The formula for index number by the method of family budget using the weighted average with weight W is equal to P0 Q0 is as follows. Index number I is equal to sigma IW divided by sigma W is equal to sigma P1 divided by Q0 into 100 into P0 Q0 whole upon sigma P0 Q0 is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100. Thus, the index number obtained by the method of family budget is the last payer's index number. Illustration 14. Compute the general index number for the production using the following data. Item: cotton cloth, grain, sugar, steel, copper, cement. Weight: index number of production 15, 220, 23, 225, 15, 190, 25, 215, 10, 198, 12, 220. Answer: item weight W, index number of production I. IW, cotton cloth 15, 220, 3300, grain 23, 225, 5175, sugar 15, 190, 2850, steel 25, 215, 5375, copper 10, 198, 1980, cement 12, 220, 2640. Total sigma W is equal to 100. Sigma IW is equal to 21,320. Index number of production I is equal to sigma IW divided by sigma W is equal to 21,320 divided by 100 is equal to 213.20. Illustration 15. Calculate the cost of living index number by the total expenditure method and the family budget method for the year 2015 with the base year 2014 using the following data. Item: wheat, rice, tur dal, oil, cloth, kerosene. Unit: quintal, kg, kg, liter, meter, liter. Quantity of year 2014: 35 kg, 25 kg, 20 kg, 10 liter, 20 liter, 15 liter. Price of year 2014 in rupees: 1600, 40, 60, 80, 30, 28. Price of year 2015 in rupees: 1800, 45, 120, 90, 45, 35. The base year is 2014. We will take P0 is equal to price of 2014, Q0 is equal to quantity of 2014 and P1 is equal to price of 2015. We shall make uniform units for the price and quantity of each item. Method of total expenditure. Item: unit, year 2014, Q0, P0, year 2015, P1, P1 Q0, P0 Q0. Weight: kg, 35, 16, 18, 630, 560. Rice: kg, 25, 40, 45, 1125, 1000. Tur dal: kg, 20, 60, 120, 2400, 1200. Oil: liter, 10, 80, 90, 900, 800. Cloth: meter, 20, 30, 45, 900, 600. Kerosene: liter, 15, 28, 35, 525, 420. Total: 6480, 4580. Index number by total expenditure method is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100 is equal to 6480 divided by 4580 into 100 is equal to 1041.4847 equals to 141.48. Thus, there is a rise of 141.48 minus 100 is equal to 41.48% in the total expenditure in the year 2015 as compared to the base year 2014. Method of family budget. Item: unit, year 2014, Q0, P0, year 2015, P1. I is equal to P1 divided by P0 into 100. W is equal to P0 Q0. IW. Weight: kg, 35, 16, 18, 18 divided by 16 into 100 is equal to 112.5. 560. 63,000. Rice kg. 25, 40, 45. 45 divided by 40 into 100 is equal to 112.5. 1,000. 1,12,500. Tuvar dal kg. 20, 60, 120. 120 divided by 60 into 100 is equal to 200. 1,200. 2,40,000. Oil liter. 10, 80, 90. 90 divided by 80 into 100 is equal to 112.5. 890,000. Cloth meter. 20, 30, 45. 45 divided by 30 into 100 is equal to 150. 690,000. Kerosene liter. 15, 28, 35. 35 divided by 28 into 100 is equal to 125. 420. 52,500. Total 4,580. 6,48,000. Index number by family budget method is equal to sigma IW divided by sigma W is equal to 6,48,000 divided by 4,580 is equal to 141.4847 equals to 141.4. Illustration 16. The details of expenditure on clothing for the worker class of a region are as follows. Find the index number for clothing by the total expenditure and family budget method. Item unit. Sari piece. Dhoti piece. Shirting meter. Other meter. Quantity in year 2010 5, 8, 20, 15. Price in year 2010 in rupees 300, 70, 32.40, 20.90. Price in year 2014 in rupees 400, 100, 38, 23.80. We will take P0 is equal to price of 2010. P1 is equal to price of 2014. Q0 is equal to quantity of 2010. Item unit year 2010 Q0 P0 year 2014 P1. Method of total expenditure P1 Q0 P0 Q0. Method of family budget W is equal to P0 Q0. Price relative I is equal to P1 divided by P0 into 100. IW. Sari piece 5, 300, 400, 2000, 1500, 1500. 400 divided by 300 into 100 is equal to 133.3. 1,99,950. Dhoti piece 8, 70, 100, 800, 560, 560. 100 divided by 70 into 100 is equal to 142.9. 80,024. Shirting meter 20, 32.40, 38, 760, 648, 648. 38 divided by 32.40 into 100 is equal to 117.3. 76,010.4. Other meter 15, 20.90, 23.80, 357, 313.5, 313.5. 23.80 divided by 20.90 into 100 is equal to 113.9. 35,707.65. Total sigma P1 Q0 is equal to 3,917. Sigma P0 Q0 is equal to 3,021.5. Sigma W is equal to 3,021.5. Sigma IW is equal to 3,91,692.05. Index number by total expenditure of clothing group I is equal to sigma P1Q0 divided by sigma P0Q0 into 100 is equal to 3917 divided by 3021.5 into 100 is equal to 1.2964 into 100 is equal to 129.64. Index number by family budget method is equal to sigma IW divided by sigma W is equal to 3,91,692.05 divided by 3021.5 is equal to 129.64. Illustration 17. The following data are obtained from the budget inquiry of middle class families. State the change in the cost of living in the current year 2015 with respect to the base year 2014 by finding the index number. If the average monthly disposable income of a family is rupees 30,000 during the year 2014 and their average monthly disposable income during the year 2015 is rupees 35,000, then according to family budget index number, what should be the rise in the average monthly disposable income of the family to maintain the same standard of living of the base year? Group, food, clothing, rent, fuel, miscellaneous. Weight 45, 20, 15, 10, 10. Percentage price relative of the group in year 2015 130, 150, 120, 160, 120. Answer. The weights W and the percentage price relatives I of the groups for the year 2015 are given here. Hence, we shall calculate the index number by family budget method. Group, food, clothing, rent, fuel, miscellaneous, total. Percentage price relative I 130, 150, 120, 160, 120. Weight W 45, 20, 15, 10, 10, 100. IW 5,850, 3,000, 1,800, 1,600, 1,200, 13,450. Index number by family budget method is equal to I is equal to sigma IW divided by sigma W is equal to 13,450 divided by 100 is equal to 134.50. Thus, it can be said that there is a rise of 134.5 minus 100 is equal to 34.5% in the cost of living in the year 2015 as compared to the year 2014. According to the family budget method index number of the year 2015, the average monthly disposable income to maintain the same standard of living as the base year is equal to index number of current year divided by index number of base year into income of base year is equal to 134.50 divided by 100 into 30,000 is equal to rupees 40,350. The required increase in the average monthly disposable income to maintain the standard of living of the family is equal to rupees 40,350 minus rupees 35,000 is equal to rupees 5,350. Uses and limitations of cost of living index number. This index number is prepared by studying the changes in the cost of living of the people of different classes. Thus, the cost of living index number is used for different objectives as follows. 1. The changes in the purchasing power of money of a class of people can be measured using the corresponding cost of living index number. If the increase in the price of item is higher than the increase in the income, there is a decrease in the real income of the earning members and subsequently their purchasing power decreases. Thus, the cost of living index number is useful to find the actual purchasing power of money and the real income. The purchasing power of money and real income can be obtained by the following formula. 1. Purchasing power of money is equal to 1 divided by cost of living index number into 100. 2. Real income is equal to income divided by cost of living index number into 100. 2. The cost of living index number for each class shows the real economic condition of the respective class. Hence, this measure is used to suggest the changes in the wage, dearness allowance, bonus, etc. paid to the people of that class. 3. This index number measures the effect of retail prices on the cost of living of people. Hence, this index number guides the government regarding the items to be controlled under special acts and the items to be kept for free trade. 4. The cost of living index number helps the government as an indicator to frame the tax policies regarding issues like price regulation and fare regulation. Moreover, it is possible to know how the living of people of different classes gets affected by imposing tax on certain items, and the tax policy can be planned accordingly. 5. The government agencies and public institutions use it as a base to determine the necessity of special facilities to elevate the standard of living of people of different classes. Limitations of cost of living index number. 1. It is not possible to construct one common cost of living index number for all sections of the society. 2. The cost of living index number obtained for a certain class of people in a certain region cannot be used for some other region even for the same class of people. 3. The cost of living index number shows the average percentage changes in the cost of living of a certain class. Thus, it is not possible to measure the changes in the cost of living of an individual. 4. It is necessary to construct separate index numbers for different classes of people as well as different regions. 5. The expenditure of the people of any class depends upon the size of the family, lifestyle, liking, habits, etc. There is no uniformity in the expenditure of all the families of the same class. 6. Its calculation is based on the assumption that the lifestyle of the families does not change in the current year as compared to the base year. In reality, the liking, habits, and choices of people change with time. Thus, it is necessary to conduct family budget inquiry at regular intervals of time and change the items and their weights. Illustration 18. The prices of 3 items A, B, and C among 5 items have increased in the year 2015 by 90%, 120%, and 70% respectively with respect to the year 2010. Whereas the prices of 2 items D and E have decreased by 2% and 5% respectively. Item A is 4 times important than item B, and item C is 6 times important than item A. The importance of items D and E is 2.5 times the importance of item B. Compute the general price index number of the year 2015 for all the 5 items. Answer. The percentage increase and decrease in the prices of items is given here. Similarly, the weight W of the items are the numbers showing their relative importance. Suppose the relative importance of item B is 1. Then the importance of item A will be 4, importance of C will be 24, and that of D and E will be 2.5 each. Item percentage increase decrease. Index number I is equal to 100 plus increase is equal to 100 minus decrease. Weight W, IW. A plus 90, 100 plus 90 is equal to 190, 4, 760. B plus 120, 100 plus 120 is equal to 220, 1, 220. C. Plus 70. 100 plus 70 is equal to 170. 24. 4080. D. Minus 2. 100 minus 2 is equal to 98. 2.5. 245. E. Minus 5. 100 minus 5 is equal to 95. 2.5. 237.5. Total 34. 5542.5. General price index number is equal to sigma IW divided by sigma W is equal to 5542.5 divided by 34 is equal to 163.0147 equals to 163.01. Thus, it can be said that there is a rise of 163.01 minus 100 is equal to 63.01% in the prices in the current year 2015 as compared to the base year 2014. Illustration 19. Find the real wages for the worker class of a city from the following data about their average monthly wage and the cost of living index number, that is base year 2001. Find the purchasing power of money in the year 2015 by taking the base year 2001 and state the importance of this answer. Year 2010, 2011, 2012, 2013, 2014, 2015. Average monthly wage in rupees 15,000, 15,600, 16,200, 17,000, 18,000, 20,000. Cost of living index number 192, 203, 228, 268, 270, 287. Answer. The calculation of real wage using the wages and cost of living index numbers will be as follows. Real wage is equal to average monthly wage divided by cost of living index number into 100. Year, average, cost of living index number, real wage in rupees. 2010, 15,000, 192. 15,000 divided by 192 into 100 is equal to 7,812.5. 2011, 15,600. 203. 15,600 divided by 203 into 100 is equal to 7,684.73. 2012. 16,200. 228. 16,200 divided by 228 into 100 is equal to 7,105.26. 2013. 17,000. 268. 17,000 divided by 268 into 100 is equal to 6,343.28. 2014. 18,000. 270. 18,000 divided by 270 into 100 is equal to 6,666.67. 2015. 20,000. 287. 20,000 divided by 287 into 100 is equal to 6,968.64. The purchasing power of money is the reciprocal of the cost of living index number of the current year with the respective base year. Therefore, we can say that the purchasing power of money in the year 2015 with the base year 2001 is equal to 100 divided by 287 is equal to 0.3484 is equal to 0.35. Hence, it can be said that if the unit of money is rupee, then the value of rupee in the year 2005 is 35 paisa with respect to the base year 2001. Thus, although the actual average monthly wage of the workers of this class in the year 2015 is more than the base year 2001, the real disposable wage in the year 2015 is only rupees 6,968.64 with respect to the base year. Illustration 20. Answer the following questions. Number 1. The price of wheat was is equal to 1600 per quintal in the year 2014 and it was is equal to 1800 per quintal in the year 2015. Find the price index number of wheat for the year 2015 with the base year 2014 and interpret it. Price index number of wheat for year 2015, I is equal to P1 divided by P0 into 100 is equal to 1800 divided by 1600 into 100 is equal to 112.5. Thus, it can be said that there is a rise of 112.5 minus 100 is equal to 12.5% in the price of wheat per quintal in the year 2015 as compared to the year 2014. Number 2. The last payer's index number is 8 divided by 9 times the Fisher's index number. If the Fisher's index number is 180, find the passage index number. The last payer's index number is 8 divided by 9 times the Fisher's index number. IL is equal to 8 divided by 9 into IF. IL is equal to 8 divided by 9 into 180. IL is equal to 160. Now IF is equal to square root IL into IP. 180 is equal to square root 160 into IP. 180 square is equal to 160 into IP. IP is equal to 180 into 180 divided by 160 is equal to 202.5. Number 3. The production of an item in the year 2015 has increased by 3 times the production in the base year. Find the index number of production for the year 2015. Consider the index number of the base year as 100. The production has increased by 3 times in the year 2015. Production index number of year 2015 is equal to index number of base year plus increase in index number in current year is equal to 100 plus in bracket 3 into 100 is equal to 100 plus 300 is equal to 400. Number 4. If sigma P1Q0 is to sigma P0Q0 is equal to 3 is to 2 and sigma P1Q1 is to sigma P0Q1 is equal to 5 is to 3. Find IL, IP and IF. Sigma P1Q0 divided by sigma P0Q0 is equal to 3 divided by 2. IL is equal to sigma P1Q0 divided by sigma P0Q0 into 100 is equal to 3 divided by 2 into 100 is equal to 150. Sigma P1Q1 divided by sigma P0Q1 is equal to 5 divided by 3. IP is equal to sigma P1Q1 divided by sigma P0Q1 into 100 is equal to 5 divided by 3 into 100 is equal to 166.67. IF is equal to square root IL into IP is equal to square root 150 into 166.67 is equal to square root 25,000.5 is equal to 158.12. Number 5. If the average monthly disposable income of middle class families in the year 2014 is rupees 14,400 and if the cost of living index number for the year 2015 with the base year 2014 is 115, then the average income of these families in the year 2015. The cost of living index number of the middle class families for the year 2015 is 115 with the base year 2014. Hence, the index number has increased by 115 minus 100 is equal to 15% as compared to the base year. Thus, there should be a 15% rise in the average disposable income of the middle class families. Therefore, average monthly disposable income of the families is equal to 14,400 plus in bracket 14,400 into 15 divided by 100 is equal to 14,400 plus 2,160 is equal to 16,560. Hence, the average monthly disposable income of these families in the year 2015 should be rupees 16,560. Number 6. If the cost of living index number of the current year has increased to 180 from the base year index number 100, and if the average income of workers has increased from rupees 6,000 to rupees 9,000, is there an increase or decrease in the purchasing power of the workers? How much is it? The index number has increased to 180 from 100 here, which means that there is an increase of 80%. Hence, the income should also increase by 80%. Average income is equal to 6,000 plus in bracket 6,000 into 80 divided by 100 is equal to 6,000 plus 4,800 is equal to rupees 10,800. Hence, the average income of workers should be rupees 10,800. But the average income of workers has increased to rupees 9,000. Thus, there is a decrease of 10,800 minus 9,000 is equal to rupees 1,800 in the average income with reference to the index number. Hence, it can be said that there is a decrease in their purchasing power. Number 7. The wholesale price index numbers of the year 2015 and 2016 are found to be 150.2 and 165.7 respectively. Find the rate of inflation using index numbers of both the years. The index number of the year 2015 is 150.2 and the index number of current year 2016 is 165.7. We will use the following formula of the rate of inflation. Rate of inflation is equal to wholesale price index number of current year minus wholesale price index number of previous year divided by wholesale price index number of previous year into 100 is equal to 165.7 minus 150.2 divided by 150.2 into 100 is equal to 15.5 divided by 150.2 into 100 is equal to 10.3196 is equal to 10.32. Thus, rate of inflation is 10.32%. Number 8. If the increases in the price relatives of three items are 250%, 265% and 300% respectively, and if the ratio of the importance of these items is 8:7:5, find the general price index number. The percentage increase in the index numbers, that is price relatives I and the relative importance W, are given here. We will calculate the index number. Item index number I, that is index number of base year plus increase, weight W, IW. A 100 plus 250 is equal to 350, 8 2800. B 100 plus 265 is equal to 365, 7 2555. C 100 plus 300 is equal to 400, 5 2000. Total 20, 7355. General index number is equal to sigma IW divided by sigma W is equal to 7355 divided by 20 is equal to 367.75. General index number is equal to 367.75. Thus, there is a rise of 367.75 minus 100 is equal to 267.75% in the prices in the current year as compared to the base year. List of formula. 1. Price relative is equal to price of current year, that is period, divided by price of base year, that is period, is equal to P1 divided by P0. 2. Quantity relative is equal to quantity of current year, that is period, divided by quantity of base year, that is period, is equal to Q1 divided by Q0. 3. Index number. I is equal to value of variable in current year, that is period, divided by value of variable in base year, that is period, into 100. I is equal to P1 divided by P0 into 100. 4. Index number based on price relatives of n items is equal to I is equal to sigma P1 divided by P0 divided by n into 100. 5. Fixed base index number is equal to value of variable in current year, that is period, divided by value of variable in base year, that is period, into 100 is equal to P1 divided by P0 into 100. 6. Chain base index number is equal to value of variable in current year, that is period, divided by value of variable in preceding year, that is period, into 100. 7. Conversion of fixed base index number into chain base index number. Chain base index number is equal to fixed base index number of current year divided by fixed base index number of preceding year into 100. 8. Conversion of chain base index number into fixed base index number. Fixed base index number is equal to chain base index number of current year into fixed base index number of preceding year divided by 100. 9. Last year's index number is equal to IL is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100. 10. Passes index number IP is equal to sigma P1 Q1 divided by sigma P0 Q1 into 100. 11. Fisher's index number IF is equal to square root IL into IP, or IF is equal to under root sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. 12. Cost of living index number. Number 1. Method of total expenditure. When base year quantity, that is Q0, is given, index number is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100. Note, this is last year's index number. When current year quantity Q1 is given, index number is equal to sigma P1 Q1 divided by sigma P0 Q1 into 100. Note, this is past year's index number. Number 2. Method of family budget, that is weighted average of relative values. Index number is equal to sigma IW divided by sigma W, where I is equal to P1 divided by P0 into 100. W is equal to P0 Q0. 13. Purchasing power of money is equal to 1 divided by cost of living index number into 100. 14. Real wage is equal to wage divided by cost of living index number into 100.